In this problem, we are given a flower bed, which is nothing but an array of plots, and any ith plot indicates whether a flower is planted there or not. That means uh, if I go to any ith location, I, and if it is one, that means there is a flower. And if it is equal to zero, that means there is no flower. So in this problem, what do we have to find out? We have to find out how many new flowers we can plant. New flowers we can plant in the empty plots. And in each plot, we can only plant one flower, right? And there is one more constraint that no two adjacent plots can have flower. For example, if we have given a flower bed like this, one, so this is not a valid input. It's not a valid because in this case we can see that there are two flowers which are adjacent to each other. So this is not a valid arrangement of the flowers in the plots. So okay, so if we look at a problem, right, like if you're given a flower bed, something like this, 1 0 0 0 1. So what we can say is if the plot is already occupied, we cannot do anything about it, right? And if the plot is empty, we have two options. We can either plant a flower or we cannot plant a flower, right? So at each ith plot, we need to ask ourselves this question: can I plant a flower there, right? And okay, so when can I not plant a flower? If it is already occupied, or its neighbor is already occupied, already occupied. That means I have to look at the three locations. I have to look at flower bed I. I have to look at flower bed I minus one, and I have to look at flower bed I plus one. If any of these are equal to one, that means I cannot plant a flower at the ith location. So I need to ask myself this question: can I plant a flower at the ith plot? So if any of these locations are occupied, that means I cannot plant the flower there. Okay. So, and let's say if the answer turns out to be that yes, I can plant the flower, right? That means uh, all these three locations are unoccupied or flower bed. In other words, we can say that they are all equal to zero. So in such a situation, right, since we have to find out, uh, right, in how many uh, empty plots we can plant a new flower without violating this constraint that no two adjacent plot should have flower. So, okay, so now we know that we can plant a flower in an empty plot. So we have two options. Uh, Option one, plant a flower at the ith location. And second option is don't plant the flower at the ith location. So for each ith plot, we will compute two values, plant of I and don't plant of I. So we saw, right? Like we have these two options at each empty plot wherever we can plant a flower. Either we plant the flower or we don't plant the flower. And what do we want to find out? We want to find out what is the maximum number of flowers we can plant in the subarray I to n minus 1. And if we plant the flower at ith location. So we saw that we had two options. If we go with the first option, so this plant of I, what does it store? It stores what is the maximum number of flowers we can plant in the subarray, starting from the ith index to the end of the array, if we are planting the flower at the ith location. Similarly, what would don't plant of I would tell that the maximum number of uh, flowers we can plant in the subarray I to n minus 1 if we don't plant the flower at ith location, right? So imagine for each ith plot, we have these two values. So in order to find out our answer, like we have this flower bed, right? And it is like this 1, 0, 0, 0, 1. So for each ith plot, we have two values, plant of I and don't plant of I. So plant of 0. So in this case, what we can see is that since uh, flower bed at the zeroth plot is already occupied, that means we cannot plant the flower there. So plant of 0 would be 0. And don't plant of 0, what would it store? It would store the answer. What would be the maximum number of flowers we can plant in the subarray, starting our first index to the end of the array, right? And that would be our don't plant of 0. If somehow we compute these values, right? So our answer, maximum number of flowers we can plant in the flower bed would be max of plant of 0 and don't plant of 0. Okay, so how do we compute these plant of I and don't plant of I? Okay, so first of all, we look at the plant of I. That means it tells if we are planting the flower at the ith location. Now, it is possible that we cannot plant the flower at the ith location because it is already occupied or one of its neighbor is already occupied. In that case, we cannot plant the flower there. So this value would be 0. Plant of I would be 0 if we cannot plant the flower at the ith location because uh, ith plot or it's one of its neighbor is already occupied. But in case we can plant the flower there, right? So that means I have already planted one flower at the ith location. Now, but in the next I plus 1th plot, I cannot plant the flower. So I will pick the value from don't plant of I plus 1. Don't plant of I plus 1, what does it indicate? That it indicates that at I plus 1 location, I'm not planting any flower. And what is the maximum number of flowers I can plant in the subarray starting from I plus 1 and going to the end of the array? So this would be our value of plant of I. And how would we compute don't plant of I? Don't plant of I tells that I'm not planting any flower at the ith location. Now tell me what is the maximum number of flowers I can plant in the subarray starting from, so the subarray is uh, I to n minus 1. That means the end of the array. So it would be your max of plant of I plus 1 and don't plant of I plus 1. Because since we have not planted any flower at the ith location, in the next location, that means in the I plus 1th location, we have both the options. Either we can plant the flower or we do not plant the flower. So we can just simply take the max of it. So assuming that we have this flower bed array as an input, and we will maintain two arrays, plant, and we'll maintain another array, don't plant. And let's say their sizes are n, the order of size n. So how do we compute these values in a program? So we can, since we can see this, for computing any plant of I and don't plant of I, we are uh, using a mixed value, right? So the smallest subproblem will be on the rightmost side. So we have to first solve it for n minus 1, then n minus 2, and then originally the biggest problem is plant of 0 and don't plant of 0. So we would start the iteration from the back of the array to the starting. So for I is equal to n minus 1, I should be greater than equal to 0, I minus minus. So first of all, what we need to check whether we can plant the flower there or not, right? So how do we check? We check whether the ith plot is occupied or its neighbor are occupied. If any of these conditions turn out to be true, we say that we cannot plant the flower there, and plant of I would be 0, and don't plant of I would be maximum of plant of I plus 1 and don't plant of I plus 1. Okay, but in a scenario where we can plant the flower, so what we'll have to do is, so plant of I. That means at the ith location, I have planted a flower. That means one I have planted, but in the next location, I cannot plant the flower. So I will pick the value from don't plant in the I plus 1. That means at the I plus 1 location, if I do not plant a flower, what is the maximum number of flowers I can plant in the subarray starting from I plus 1 to the end of the array? And what would be the don't plant of I? It will be the same, this particular value. So eventually to find out what is maximum number of flowers that we can plant in the flower bed, it would be your max of plant of 0, comma, don't plant of 0, right? And in this case, we can see that since we are doing these I minus 1 and I plus 1, we'll also have to take care of the edge case scenarios. So that is something we can take care of. Apart from that, in the original question, the input was something like this, that we were given an integer n, and we need to tell whether we can plant n new flowers or not. So what we can do is we can just simply compare the maximum number of flowers with the input n. If the maximum number of flowers that we can plant in the flower bed is greater than or equal to n, that means we can return true, otherwise we can return false.